start going over these, or at least putting in the answer. So the first one should be 4 over 5, sorry, x squared y to the 7th. Yeah, sure. So 6 goes into 24 4 times, right? And 6 goes into 30 5 times. Okay. And then there's 3 x's on top and 5 on bottom, so the 3 can go away and there will be 2 left on bottom, right? And then there's 1 on top and 8 on bottom, so 1 goes away on top and there will be 7 left on the bottom. There you go. So on the second one, the 4's go away, the x goes away, right? So I get 1 over x. And on the third one, the 2's go away, and that becomes 2. And the x's on the bottom go away, and I get 1 on the top. And the y's on the top go away, and I get 1 y left on the bottom. So I get, no, not a 1, sorry. Bless you. There's an x left on top and a 2y left on bottom. And then number 4, I can factor a 3 out on the bottom and I get 2x minus 3. And then 3 goes into 21 7 times. So it's 7 over 2x minus 3. Number 5 comes after 4. That's really good. Okay, so factor a 3 out on the top and I get x minus 4. A 3 out on the bottom and I get x plus 5. And I'm going to get x minus 4 over x plus 5. And then, where's the next problem? There we go. I think that this factors to x plus 8 over times x minus 6. Wow. All over x plus 8. And then those can go away. So I get left with x minus 6. And then for the last one, I think I factored out a 7b on the bottom, and I get left with b minus 7. So again, those go away. I actually didn't go away. I made a 1, so I get 1 over 7b. Questions? Everyone okay? Awesome. So now we're going to talk about what we're doing today is we're multiplying and dividing. And, you know, normally when we start a function, right, when we start a new type of function, we start with adding and subtracting. We don't with rational functions because adding and subtracting is harder than multiplying and dividing, which is totally backwards of any other function that you get, right? Usually adding and subtracting is easier, not with rationals, because rationals are fractions. And we all know that adding fractions is harder than multiplying fractions, right? Because we have to have a common denominator. So we start with multiplying and dividing. So rational expressions consist of a polynomial divided by a non-zero polynomial. So we just put in another little definition that kind of corresponds with our definition from last class that we gave. So all of these are examples of a polynomial. So the product of the polynomials, if I have 2 fractions I'm multiplying together, when I multiply numerator times numerator and denominator times denominator. I just multiply straight across, top times top, bottom times bottom, right? And then neither one of the bottoms can be equal to 0. Okay? So that's how I multiply fractions. When I divide fractions, what I do is I take that second fraction and I take the reciprocal of it, right? I take it and I flip it, and then it becomes multiplication. Okay? So basically, all I'm doing is multiplying the whole time. Unless it's divide, I have to flip first before I multiply, but I'm multiplying, okay, when I'm doing fractions. Now, in this case, when I'm talking about rationals, instead of multiplying right out off the bat, I'm not going to do that. I'm going to factor. Remember what we did yesterday when we simplified is we factored. This is basically what multiplying and dividing rational functions are, is we're going to factor everything, cancel everything out, and what's left is what's left. And that's our answer. So here we go. So I know it's kind of big and it's kind of ugly and it's, right? But all we're going to do is factor. We're going to factor everything, okay? So I'm going to go ahead and start by factoring the top over here. 7 comes out of that, right? Yes, so that's x minus 2. And then the second piece, the only multiples of 5 are 5 and 1. And the only factors of 1 are 1 and 1, so that's pretty easy to factor. So that's that. And then the denominator, x squared minus 4 factors to, what does it factor to? X plus 2 and x minus 2. And then 35x plus 7, I think I can take a 7 out of that, and I should get 5x plus 1. Okay, notice all I did was factor. I just factored everything, okay? And now I'm going to go through and make ones. So I have a 7 in the top and a 7 in the bottom. And I have an x minus 2 in the top and an x minus 2 in the bottom. And I have a 5x plus 1 in the top and a 5x plus 1 in the bottom. And now everything that's left is my answer. So my answer would be x plus 1 divided by x plus 2. Done. I don't really have to multiply anything, even though I'm multiplying. Okay? Can you guys see that back there? I'm trying, it's as big as I can get it and still write on my iPad, sorry. I know there's more room on the board, but there's not more room on my iPad. Okay. Any questions at home? Are we okay? So far? Honestly, it really doesn't get any harder than this. Okay? So some of the factoring might be kind of funky, but it's not getting any harder than that, okay? So I do want to remind you, I know we did it, it's been a while since we've done factoring of cubes. So we have a cubic expression right here. In the x cubed minus 27. And if you remember, if I have a cubed minus b cubed, I'm just going to write what the formula is, right? It becomes, okay, I'm going to do this off the top of my head, so I hope I remember it right. A minus b times a squared plus a times b plus b squared. Yeah, that's it. Okay. So on this I'm going to highlight it. This one right here is a cube. So because 27 can be written as 3 cubed, right? So it's a perfect cube. So A would be x and B would be 3. So I'm going to take those and I'm going to factor it this way. So I get x minus 3 times x squared plus 3x plus 9. And then, oh my goodness, and then this other part, I think I can factor an x cubed out of this. So I'm going to just take an x cubed there. So if I take an x cubed out, I get what? X squared minus 6x plus 9. Okay, and so that factors to, what does that factor to? X minus 3 and x minus 3. Please, if you have any questions about any of the factoring I'm doing, please let me know, okay? And then out of this one, I can take an x squared, and it becomes x squared minus 9, so that's x plus 3 and x minus 3. And then this doesn't factor, x squared plus 3x plus 9. But if we look at making a 1, there's that and there's that, that's gone. And the x squared leaves just a single x on top, x minus 3 and x minus 3. And I get left with x times x minus 3 squared all over x plus 3. I don't have to multiply out the x minus 3 squared times x. I can just leave it like that. Pretty sure in delta math, just so you guys know, you don't have any cubics that you have to factor. Okay? Any questions so far? We're okay? It's not too bad? Okay, let's go ahead and do A, B, C, and D. Beautiful. I'll try and keep 1 and 2 up there too so you can see it. Okay guys, let's go ahead and go over this. So on A, if you kind of just look at A, I don't necessarily have to factor. If I can already say, look at this, those is on top and the bottom, and I can just cross them off. I'm already going to cross it off. If I factor, I'm still going to cross it off, right? So it's just kind of like, if it's the same on the top and the bottom, I know I'm going to make a 1. Whether I factor it or not, I'm still going to make a 1. So in this case, I might not factor the 2x plus 6. I'm just going to cross it off. Does that make sense? So my answer for A is just what's left because there's no factoring in what's left. So x plus 5. So x minus 7 and x plus 5. And that's it. Just because I can look at it and say, oh, well, I have the same thing in the top and the bottom, and that makes it 1. So I think B is fairly similar. Except I will have to do a little bit of factoring still. So I know the x plus 5s go away. And let's see, so I have x minus 6. And in the bottom, 7x is going to be x plus 1. So there's no more canceling I can do. So this is my answer, and I'm done. I'll try and write bigger. I'll try and remember to write bigger. Sorry. Okay. C, again, I have 2 things that I know will make a 1, so I know that that's going to go away and that's going to go away. So now I only have to factor the top, which is going to factor to x plus 5 times x minus 1. And the bottom is going to be x minus 7 times x plus 5. And so I have a 1 there. So my answer should be x minus 1 over x minus 7. Questions? Are you okay? Serena, can you see that? Do I need to make it bigger? Are you okay? Yeah. Okay. Just want to make sure everyone can see. All right, and then I don't think on D we can do that. Unfortunately. So let's see. I think I can factor out a 4x squared. And I get left with 3x plus 1. And then I can factor out a 3, and I get left with x plus 10. So there's my numerator. And my denominator, what multiplies to be 4 and 10. So x plus 4 and x plus 10 and x minus 4. Wow. And then I can factor another 3 out, and I get 2x, 3x plus 1. So I've got an x plus 10 and x plus 10, a 3 and a 3, 3x plus 1, 3x plus 1. So it looks like my answer is going to be 4x squared over x minus 4. Questions? Is it okay? It's not too bad, right? Okay. I know for some people it could be kind of bad, but it should be, if you're okay with factoring, it should be okay. All right, so now we're going to move to division. So we've done multiplication, now we're going to move to division. The difference between multiplication and division is before I can cancel, I'm going to take this second fraction and I'm going to flip it, and then it becomes multiplication. So the second fraction becomes flipped. So I'm going to factor the top again. So I'm going to get 5x minus 2 and 5x plus 2. And then I get x plus 3 in the numerator. And then I'm going to get, let's see what I'm going to get down here. X plus 3, x minus 3. And then out of this one up here, in order to make it cancel out, I need a positive 5x. So I'm going to factor out a negative 1. And that turns this into a positive 5x minus 2. Because what happens if I take a negative out, it changes my signs, right? So it changes my my positive 2 to a negative 2, and my negative 5x to a positive 5x. So now I can make a 1 with this one, and that's gone. And then the plus 3s are there. So my answer should be, what should my answer be? 5x plus 2 over negative x plus 3. I just took the negative and distributed it through this. So that's how I got the negative x plus 3. So I went and did this. Okay? Questions? Okay, next example, same thing. I'm going to flip this one. So I've got x plus 4 and x minus 4. And let's see, what do we have here? Minus 7 plus 5. Okay, all over x minus 5 times x minus 5 times 3 times x minus 4. Yeah, I don't think I factored the top one right, because 7 times 5 is not 10, is it? Wow. Okay. So multiplies to be 10. So that's got to be negative 5 and positive 2. Does that work better? That works better. Okay, so the negative 5s go away, and the negative 4s go away. And I'm going to get, as an answer, x minus 4 times x plus 2 all over 3 times x minus 5. Oh, yes, thank you. Thank you, thank you, thank you. Should be this one that's crossed off. And this one that's good. Thank you, thank you, thank you. Yes. I think that's it on this page, right? Okay, so go ahead and work on these 4 problems. So I'm going to flip the second one, and I get 1 times 2x times x plus 1 all over x plus 1 times 2. So those go away, the 2 goes away, and I get left with x. Okay, so on this one, I'm going to flip these 2, and I get 10n times n squared minus 6n plus 8 all over n squared minus 6n plus 8 times n minus 10. and these cancel out or make a 1, and I get left with 10n over n minus 10. There we go, done. Any questions so far?
Are you two supposed to be in a class somewhere?
Thank you for saying
Why do
so.
you have your mask off? Well, I can get you a new one.
So this factors to x plus 6 and x minus 4. And then I'm going to flip this and factor out a 3x squared. And I get x minus 1. And then in my denominator, I'm getting x plus 6 times x minus 6. And minus 4 and minus 1. X minus 4 and x minus 1. So x plus 6 and x plus 6. I want to make sure I cross off the right ones today. X minus 4 and x minus 4. X minus 1 and x minus 1. So I'm going to get left with 3x squared over x minus 6. Okay, questions so far? We're doing okay? Awesome. And then the last one, well, kind of the last one, r minus 4, switch this one, times 7 times r minus 9, all over r minus 9 and r minus 4, great, times 7 times r minus 9. Oh no, sorry. I didn't flip the second one. Sorry. I was like, why is that the same? Because I forgot to flip it. 9r squared times r minus 8. There we go. That looks better. Okay. So the r minus 9 and the r minus 4 are gone. And then that's it. Then I've got my answer of 7 over 9r squared times r minus 8. Okay? Okay, nice job. So now we're going to look at some complex fractions. Okay? So basically, it's just another way to write division, right? So it's a fraction divided by, remember, divide bar means, a fraction bar means divide. Oh, wow. So I have a fraction divided by a fraction. So they're just writing it a different way. So we still do the same thing. I still take that second fraction, the second fraction here, I flip it, and then it turns into multiplication, right? So even though they've written it a different way, I'm still doing the exact same thing. I'm doing the exact same thing. I don't know why this is labeled A, but we're just going to go ahead and do it. So I'm going to flip it, right? I'm going to rewrite this as, I can actually rewrite it as 10, x over 10 divided by x over 4. Now it's in a form that we're used to. So if I flip this, so I've got x over 10 times 4 over x. Now you can see that the x's cross out or make a 1. And 2 goes into 4 2 times, and 2 goes into 10 5 times. So my answer should be 2/5. Okay. And then we've got 2 more problems. If you guys can go ahead and work on those 2. And then we will be finished with today. The answers for these 2. Remember, I'm going to take this one, I'm going to flip it, right? So the top becomes the bottom, bottom becomes the top. So if I take a 2 out of the top, I get x plus 3, and then x plus 2 when I flip it. And my denominator is going to become, take a 5, and I factor the 5 out, and I get x plus 2. And then x plus 3 times x plus 1. So the plus 2's make a 1 and the plus 3's make a 1. And we get left with 2 over 5 times x plus 1. Parenthesis. Question? It's okay? Not too bad? Awesome. Same thing with this one, right? I'm going to flip the second one here. And I've got, what do I have? X minus 4 times x minus 1 times x all over x squared times x minus 1. So the x minus 1's will go away. One of the x's go away. So I'm going to get left with x minus 4 divided by x. Okay, awesome. So that's it for today. I know at the bottom of the page there's a self-rate thing, which we're not doing because we're now doing it in the in Canvas, right? So you go to the self-evaluation page in Canvas and do it there. And then there is homework in Delta Math. Please, I'm going to try. I have time. We have about 30 minutes. You can work on the Delta Math. And I should be able to get grades updated in that 30 minutes for any of you who've worked on checkpoints or homework in that time.